Okay, so in the beginning I will start with this exercise. Where I am interested in getting the Fourier transform of the function noted ft, which is the gate function between -1 and +1. So by definition, the Fourier transform of ft is noted f of omega, and it is the integral from -infinity plus infinity of ft exponential minus j omega t dt. This function will be equal to integral -1 to +1 because the function is existing on a limited support of time. So it will be 1 exponential minus j omega t dt. Direct calculation of this Fourier transform will be 1 over minus j of omega exponential minus j omega t evaluated at +1 and -1. And this will give f of omega equal to minus over j omega exponential minus j omega minus exponential my plus now j of omega. So I will put f of omega in the form, so the minus, I will write it exponential j omega minus exponential minus j of omega divided by 2j, and I will multiply it by 2 over omega. So the term between brackets, it is nothing but the sine of omega. So this will be 2 over omega times sine of omega. As a result, I can write f of omega will be equal to 2 over omega sine of omega. And this will be the Fourier transform of the gate function, which is existing from -1 to +1 with an amplitude equal to 1. So this is ft versus time. How about the rect function, which is defined on the support of time minus t over 2 to plus t over 2 with an amplitude equal to 1. So here this is the rect function all time. So the Fourier transform f of omega will be the integral from minus t over 2 to plus t over 2 of 1 multiplied by minus j omega t dt. So this gives the Fourier transform f of omega equal to t sine of t over 2 omega divided by t over 2 omega. And this will be the final answer of the Fourier transform of the rect function, which is existing from minus 1 to 1. So this is the function in t, and this is the rect function.